However, if you're still relatively new, we'll do our best to bring you along. All right, so let's get started. So in case you weren't already familiar, CloudFront is AWS's content delivery network service, which essentially means it's a service that focuses on helping you accelerate and protect web content delivered over the public internet. Now, it just so happens, this month, the service reached its 15-year anniversary, which is a huge milestone for us. And as you can see from this timeline, it's grown quite a bit since the original launch. In 2008, we launched with only 14 edge locations around the world, and over time, we've continually added more locations and added features to the network. Today, we're actually in over 100, or sorry, let me start over. We have over 600 edge locations deployed around the world. We're in over 100 cities and 50 countries around the world. We also have 13 regional edge caches that are deployed as a mid-tier cache within our network architecture. On top of this, between the edge locations and our AWS regions, we connect them using the AWS Global Network. This is a privately managed network managed by AWS mainly to provide better performance and reliability when routing traffic around the world. Now, as you can see, we've grown the network quite a bit since the original launch, and a lot of this growth really has to do with the growing number of customers running critical workloads on CloudFront. So, as you can see from this slide, we have customers across a wide variety of industries, from media and entertainment to gaming, financial services, retail, I mean, you name it, right? This is just really a short list of some of the customers, and hopefully you recognize some of these brands. But ultimately, it's all of our customers that dictate how we continue to evolve the service, adding more features and capabilities over time. So in today's session, I'm going to dive into some of those core requirements that many of our customers are really looking for when they come to us asking for help with web delivery. And the first one is caching. Caching is basically table stakes for any CDN. You have to be able to do it, you have to be able to do it well, and the reasons that you want to cache in a globally distributed network has largely remained consistent over time. However, what we have seen change is the content that's being served over the network. In the early days, many of our customers were really serving largely static content because they were using their company websites just to share information broadly with their customers. But over time, they've also evolved to have way more interactive web experiences, way more dynamic content, and way more personalized content. And for us, what that means is we had to adapt as well. We're seeing a change in terms of the access patterns, the volume content that needs to be cached, and the expectations of the cache itself. So in 2008, when we launched, we had 14 edge locations, and as we added more customers to the network, we continued to expand the network, adding more locations. It extended our reach, increased our capacity. However, something that we quickly realized was to provide better performance, caching performance specifically for our customers, we couldn't depend specifically on the cache width that's available at each of those independent locations. So in 2016, we added regional edge caches. Regional edge caches are mid-tier caches that we've deployed around the world in our AWS regions. Essentially, they're super pops with really large cache widths. And what they allow us to do is collapse any request that's a cache miss from the edge pop to a nearby regional edge cache. When we deployed it, it was great. Customers instantly saw an increase in cache hit rate. For us, it also provided a number of benefits. We could add more edge locations without increasing load on our customer origins. So today, we have over 600 of those. In 2020, we introduced Origin Shield. Origin Shield is a feature that you can actually configure to turn one of those regional edge caches into a third tier of caching. So whenever there's a cache miss at the regional edge cache, that request would then collapse to the Origin Shield location. This is great for customers with either really large content catalogs like video libraries looking for better cache hit rates, or customers with sensitive origins looking for more offload. Now, when we work with customers on a caching strategy, we're really looking at a number of different things. The first thing that we look at is the popularity of the content and how that might affect its chances of getting a cache hit when a request is made. So I just showed you, within the CloudFront architecture, we rely on a tiered caching strategy to increase the chances of less popular content to be available in the cache. When we're working with customers, we're looking beyond our network. We're looking from the client all the way to the origin servers at places where you might want to be able to cache that content. The other thing that we're looking at is how mutable the content is, how frequently it's going to change or how quickly it's going to expire. In the early days, many of our customers were really just caching static files like CSS and JavaScript for very long periods of time. They would set TTLs for up to a year. But the web experience has come way more dynamic. And we've learned that there's a lot of value in caching content that's very short-lived as well, in the order of seconds. And the best way to do that is to provide capabilities to tune your cache on a per object basis. So what we recommend doing is using cache control headers, which is part of the HTTP standard, but we also have configuration and controls built into the native services itself. The next thing that we're looking at is how shareable the content is. As I mentioned, the web experience is also becoming way more personalized for individual users. And what that means now is customers have data sets that are unique to either a single user or maybe a handful of users. The content may not change a lot, so it probably makes sense to cache it. But due to the nature of the small audience, the popularity might be low, so competing for cache space could be a challenge. In these cases, we actually recommend caching this content within the client, such as the browser. The last thing that we're always looking for when we're working with our customers is opportunities to leverage the cache to provide the most performance and efficiency for your application as possible. Right? Within the HTTP standard, there's capabilities that you can leverage, and there's leniency depending on the workload to potentially serve content that maybe have expired and still exists in cache. If you're having issues with your origin, maybe you want to leverage negative caching to provide a good, consistent experience for your end users. If you're not super strict in terms of the expiration of a TTL, maybe we want to serve slightly stale content while we're refreshing that in the cache. So all of these attributes are things that we're looking at, and it's really a combination of them that you can consider when you're coming up with a strategy for your application. So the next thing I want to talk about is dynamic content acceleration. In 2012, we launched dynamic content acceleration. As our network got bigger, we had more reach, and we realized there's actually a lot of value in serving content across large distances over our network rather than going direct to origin. Specifically, when I say dynamic content, I mean content that is not cacheable. Now, the first thing we always get asked is like, how does this really work, right? Because we're adding an additional hop to the request response path, which is a fair observation. And the answer is we do a number of things. The first thing that we do is we optimize the connection by reducing the distance to establish a TLS connection between the client and the server. Now, if you're familiar with TLS and TCP, usually there's a number of round trips that have to happen, and when you're doing that over a large distance, you're incurring a lot of latency before you can even send any request packets. The second thing that we do is we maintain persistent connections from the edge pops to your origin servers. Now, when we do this, we're actually able to reuse those connections not just across a single client, but across multiple clients. And on top of that, we're always tuning these connections so that we can scale them up faster and provide better throughput. The last capability that we have really distinguishes us from other providers in that if you're hosting an origin within AWS, we're able to use the AWS global network to route the traffic to the origin. Now, when you route traffic over the public internet, you're often bound to the conditions of the network at that point in time. The routes may change, and there may be some packet loss and congestion here and there. With the AWS network, our network engineers are constantly monitoring this network, forecasting the capacity demands based on the observations we see from customer traffic over AWS's border, and scaling accordingly. And we take this investment very seriously. In 2012, we were actually one of the first providers to move to 100 gigabit Ethernet connections at our peering connections. 10 years after that, which was last year, we already announced that we're moving to 400 gigabit Ethernet connections. And when we monitor the network, we've actually seen quite a bit of an advantage. Over long distances, we've seen a reduction of up to 2x in network jitter and 30% in network latency. So in the last slide, I talked about optimizing the connection by reducing the distance to establish the connection. Now let's talk about how you can improve the performance of your application just by using the right protocol or even sometimes the latest version of the protocol. HTTP, TLS, TCP, all these protocols have been around for a while. With each iteration, they've gotten better, right? They become more efficient or more secure. And something that you can kind of do right out of the gate is just use the latest protocol and test it out to see if it's a good fit for your application. For example, within CloudFront alone, when we moved from TLS 1.2 to TLS 1.3, we instantly saw a 20% reduction in first byte latency. And when we turned on session resumption, it jumped to 50% improvement, right? Now, one thing that's worth noting is, while the protocols are out there and anyone can implement them, implementing them is an investment. A good example of this is last year we announced the support for HTTP3 over Quick Protocol, which is a protocol built on top of UDP. And to take advantage of some of those connection migration capabilities and single round trip connection establishment, we ended up building our own termination layer to really optimize it for the best performance possible. The nice thing about using CloudFront is you can offload all that work to us, right? And you can deploy, test, and tune, and figure out what's the right protocol for you. And testing it is important. Having the ability to configure something at the CDN, maintain your existing protocol from the edge POP to the origin server is something you can take advantage of. For instance, we see customers today still who are attempting to move from HTTP 1.1 to 2.0 to take advantage of some of those multiplexing capabilities to stream multiple requests over a single connection. When they turn it on, something that they might learn is their application servers aren't scaled to handle the spikes in requests of the flood of traffic that's concurrently happening over that stream, so they can quickly roll back or build queuing over time and then turn it back on. So these are all things that you can consider. Another trend that we're also seeing continually grow over the years is the growing need for bidirectional communication. Now, WebSocket protocol is a protocol that we've supported for some time now, and it's pretty much the standard because it's supported by a lot of the clients, such as browsers, right? Something that is worth noting, just by the way, some examples of these use cases: live scoring updates, chat applications, interactive in-game experiences. These are all kind of things we're hearing from customers on the use cases for these protocols. But we're always listening to our customers, right? And last week, we actually announced support for gRPC. gRPC is a protocol that's also been around for a while. It's built on HTTP2. It's great for low latency network connections, and it's built on a binary format protocol. So, traditionally, this was really designed for server-to-server communication. But as we've spoken to some of our customers, they've explained that, for custom applications, such as mobile devices, this is a protocol they really want to take advantage of. So we're proud to share that we're supporting that now, and it actually just launched this past week. Next, I want to talk about some of the functional capabilities that customers are expecting from a modern-day CDN, right? And adaptive web delivery is becoming a pretty common trend these days. So clients are changing. They're continually evolved. There's a huge variety of them. Network conditions are always changing. There's more mobile networks. The reach is getting longer over that last mile than ever. And for application owners, what they want to know is what exactly the client environment is like. They want to be able to respond to these environments to provide the best end user experience as possible for their customers. What that means for the CDN is we need to be able to provide the capabilities to help them with that. As we're working with our customers, we're learning that application architecture is no longer just within the origin. It's extending to the edge. It's extending to the CDN. So we have to provide the granular configuration capabilities, compute capabilities at the edge, and it all has to be developer friendly. So CDN is no longer an administrative task. It's now part of application architecture in itself. With CloudFront, we have a number of these capabilities built in natively to the service. However, for the sophisticated use cases, we have edge functions. In 2017, we launched Lambda at Edge. Lambda at Edge is an ability to invoke Lambda functions that are replicated around the world from your CloudFront configuration on the request and response path of that request flow, right? It's designed for sophisticated use cases. You write some Python or Node.js code. You can integrate third-party software into your CloudFront configuration. You can make network calls. In 2021, we added CloudFront functions. CloudFront functions are lightweight functions. They're JavaScript functions designed for high-volume, low-latency use cases. They can scale up to millions of requests per second. They're designed to execute in sub-millisecond time. There's a lot of value in being able to do things like request manipulation on the fly directly at the edge. They're deployed directly in our edge POPs. Last week, we also announced a new feature called Key Value Store, which was a huge rush to get to reInvent, by the way. But Key Value Store is exactly how it's described. It's a data store that's deployed directly at the edge location, and it allows CloudFront functions to make calls to the Key Value Store. Now, with Key Value Store, we unlock a number of capabilities. You can now decouple your application data from the function code itself. This allows you to do a number of things. You can make those calls in really efficient timeframes, like microseconds. And from our customer standpoint, here's some of the use cases that we've seen them use. Rather than deploying function code every time you need to make a configuration change or update a feature flag, you can now make an API call directly to the edge POPs, and they'll get updated and propagated around the world. Another interesting thing about Key Value Store is with the launch of Key Value Store, we introduced a new runtime. This new runtime actually allows you to write more efficient JavaScript code. It opens up the capability to do asynchronous operations using some of the common JavaScript modules. So to give you an idea of how customers are using CloudFront and Edge functions to optimize their web delivery, I'm going to walk through a few use cases now. And the first use case that we see is one around network conditions. Oftentimes we talk to customers and they say, hey, if our end user is on a spotty network connection, we want to serve a degraded experience to them so that they can at least have some functional use case. But we need to be able to understand when they're experiencing that and integrate it into our Edge architecture. So how do we do that? Within many of the client protocol libraries today, you can actually make calls to determine how expensive that network path is. For instance, this is a call that we pulled from an iOS library. Now, if you get a response that says, hey, we don't really have a good network connection, one way that you can let the server know to serve maybe a degraded experience is to use the save data header. With the save data header, we can now pass that along with the index request, right? And on the CloudFront function itself, we write a simple if statement to say, hey, let's rewrite this URL to a path that actually serves that bandwidth saving version of the site. Another example is we have customers using Edge functions to optimize for latency and performance. One of our customers, IMDb, actually identified a use case for this where if you're familiar with CORS, CORS is basically a standard that's used to make sure that cross-domain sharing of assets is allowed. And part of this protocol is to send a pre-flight request to validate that, hey, this domain has access to this asset hosted on another domain, right? If you have a network call that could potentially affect the performance of the server, it's actually required for the browser to send this pre-flight request. Now, what our customer realized was, as more and more customers started hitting their endpoint, there was more pre-flight requests, and their origin was hosted in one AWS region. So as a result of that, they incurred an additional round trip before any actual request could go through to serve the actual data. So they experimented with it, they tried caching it, and they saw some benefits there, but the variety of the requests and the domains that came in was good, it helped. But then they started experimenting with Edge functions, and when they did that, they realized that they could shave 200 milliseconds off of the request. Now, to expand on this architecture, if you think about Key Value Store, when you're dealing with a use case like this, if you ever had to dynamically change those domains that you want to approve, you can now do an API call to the Key Value Store rather than updating the function code. The last use case I want to talk about is client consideration. As I mentioned, we now have clients of all different types, from smart TVs to web apps to Android or iOS. The experience could be different depending on what client the end user is using. And within CloudFront, we have native capabilities to tag and identify that by inserting an additional header, some of the headers that you see here, right? Now, for really advanced use cases, sometimes our customers want to optimize for things like SEO crawlers. We have some customers that are still doing, client-side rendering with their web applications, and they may rely on CloudFront and CloudFront functions to do things like dynamic rendering. So in this example, if CloudFront detects that it's a crawler, and I'll talk a little bit more about bot detection later on in the presentation, but with AWS WAF integrated into CloudFront, you can actually detect specifically what type of bot is hitting your endpoint. From there, you can make a Lambda at Edge function call to determine where you want to route that traffic. Maybe you'll route it to an SEO optimized version of the website. All right, so with that said, I want to hand the mic over to Harish Kapalia, who will share how Capital One's been able to leverage some of these capabilities for their workloads.
Thanks, Tino. So in the earlier slide, Tino showed that we can use CloudFront function for A/B testing, and that's what we are going to talk about today. But before we discuss the implementation of that, I just want to give a brief overview of the product where we implemented that. So myself and Kevin are part of the financial services division in Capital One, where we are building products for our auto buying products and the car dealerships. Auto Navigator is one of the products where the car buying customer can go and search for the car. This tool also offers the ability to view the real financing option so the customer doesn't have to guess. They can go ahead and pre-qualify themselves with no impact to their credit score, and if interested, they can also share their contact information with the dealership. And with each car, they get a real payment option with the APR rate and stuff, so they can change their terms or they can pick a new car altogether. So with Auto Navigator, they can generate an offer, go to the dealership, take a test drive, and just walk away with the car. So it's that easy. Now the product and the business on our side, they always want to test like multiple variations of this page, be it pre-qual, be it like the car search or anything. So this they do to check the effectiveness of the UX design and how our customers are reacting to these changes. So as an enterprise, as an organization, it's very important for us to gather learnings and test our hypothesis against and validate against the customer outcomes. So what we were looking for is a technical solution for a multivariate A/B testing and which provides real-time visualization of key metrics, is easy to integrate, faster time to market, and is easily adaptable by other teams. So with that in mind, we had 4 critical requirements for the A/B testing. The first of one was it should be easy to set up. It should be pretty simple and quick to plan, set up, execute the test, and analyze the results. The second requirement was server-side rendering. Now, why do we need server-side rendering? I will come back to that in a minute, but server-side rendering is exactly what it sounds like. It means that the page is rendered on the server side. So users can view the content much faster without having to wait for JavaScript or CSS files to load. And as I said, why do we need server-side rendering? Because of the SEO requirement, which is the search engine optimization. When a page is server-side render, it's very effective when a user is actually having trouble with the slow network connection. And when the page or the content of the page is rendered before even the page is loaded, the search engines can easily crawl and index the page. The social media crawlers or the search engine bots, they don't usually like the JavaScript rendered content. So since social media sharing was an important part of our marketing strategy, the search engine or the server-side rendering was a better option. The fourth requirement was the great user experience, which is clear and intuitive navigation. So whatever the variation we are rendering, it should be easily navigable by the customer. The responsive designs, as more and more customers are using mobile, so responsive design is a very critical requirement. And third was the engaging content. So the content which aligns with the user needs and expectation is very critical for us. So what all things basically, or what all we tested using to implement this A/B testing? So the first thing was like an in-house solution. So the clients will make a call, they will get a variant version as a part of the response. The second thing was contextual bandits. The difference between contextual bandit and a simple A/B testing is the contextual bandits implements a machine learning algorithms and divert the traffic to high-performing variations, and it reduces the traffic where the variations are underperforming. The third was third-party off-the-shelf tools. All these solutions were great. There was one major drawback with all these solutions. All these solutions were API-based. So just to retrieve a particular variant version, it took a lot of time. As you can see, basically the network hop it has to traverse. So suppose today you're in Vegas, you are getting routed to US West. And then from US West, I'm making a call to the API which is hosted on East because we are running active passive. And it's not direct call actually. So consider the WAF, the ALB, and the Route 53. It just keeps adding to the latency. And the other thing is, what we are doing is on that API solution, it's not the variant, it's just the variant version. So we are bundling the entire code base into one. So whatever the variant version is getting retrieved, everything is bundled in a single code base. Doesn't matter what a variant is getting rendered. So what we were looking for is basically the ability to test independent variations, which can lead to true comparisons. So to talk about that, I will hand over the mic to Kevin, and he will discuss the implementation details.
Thanks, Harish. Okay, now for the fun part. So, user experience testing. I'm going to dive just a little bit deeper into the actual problems that we were seeing. Okay, so one of the things about everything bundled up, as Harish was saying, right, is that size is a killer to performance. Okay, and when you have larger packages, all the variants are burned in, all of that stuff, it took longer to download, it took longer to interpret, and it took longer to render, right? And with that comes hits, right? You're gonna take an SEO hit, you're gonna take a user experience hit. Google was just giving up on us. We had 0 indexing. You couldn't find us on the internet. It was a bad day, right? The user experience, again, it was definitely one of those like less than impressive, okay? So what did we do? We said, okay, we got to get the server-side rendering in place, right? We got to get SEO. People have to be able to find us, right? So step one, let's go. We're going to do some server-side rendering. Well, we started server-side rendering, and what we found was, wow, control always won. Why is that? Well, because when you only server-side render and you rehydrate, or you still have the rehydration requirement, right, on the front end, it works well when control equals control, right? But every single time you deliver control and then the variant is selected, yeah, that kind of looks pretty messed up, right? Like people bailed on the variant every single time because it looked like, hey, I got delivered one page and all of a sudden it just disappeared and I got this brand new page, right? It made people very nervous, and so we had tremendous bailout rates, okay, for any variant. So here we're thinking, wow, control must be really solid because no one uses a variance, right? So once we learned what was actually causing such a high bias toward control, we went ahead and said, okay, we need to implement something, right? And what we decided to do was leverage CloudFront functions, okay? So what we did is we literally took advantage of the 600 nodes, right, that AWS has, and we wrote a function that is deterministic, right? If given the same input, it'll always generate the same output, okay? Then what we did was we put that at the function level, okay? We built a config so that we could dynamically allocate whatever we need. We stored that on S3. We had to create an entire pipeline to push both the function and the S3 because they had to be burned in. And we'll get to why I love key value. But in our current solution, what we have is the synchronization between the file that's on S3 and the function itself. You have to take that same config, right? That same JSON object, and you have to burn it into the config itself, okay? So with limits of character size and execution time and all this other stuff, you kind of burning the candle at both ends in that case. But it was a beautiful solution, right? As it comes in, what we do is we modify the path, right? And so when anybody asks for index, we kind of roll our dice. We make we kind of roll that algorithm. If they don't have a sticky cookie, then we will generate one on the fly. We attach it to the request. It'll go back and be set at the client so that the next time that they come in, they are literally stuck to that same variant. Because again, deterministic, so same in, same out, right? So then what we did is we took that exact same algorithm and we stuck it in the client itself, right? So when the client goes to render, it looks, now every single time the client goes to render, we've always already set that cookie, right? So it looks at the cookie, same thing, determines everything's the same. It was a beautiful solution. It was so good that we gave it to product and they went nuts. I mean nuts, okay? They have run hundreds of tests, okay? We've tried all sorts of different types of home pages and all that stuff, right? Everything that Harish was talking about, you know, prequels and all this other stuff, right? Even to the point where they wanted to geolocate things. So, you know, if they wanted Vegas to be the only city that gets a certain variant, we could do that, you know? And that's the beauty of the CloudFront function. It's not just this A/B, you have access to a lot of things, and it opens the door, right, to being able to do some very sophisticated testing. So this is our full page testing. And again, I referred to the fact that the one on the left, right, that was control, the one that always won, right? And so we always thought, hey, a rich experience like that is gonna beat a simple experience every single time, until we finally separated out and actually applied actual speed to the two. And what we found out, speed wins every time, okay? The variant crushed control. I mean, crushed it, like not even a race, okay? So with that, man, we improved click-through rates, okay? Our conversions went up. I mean, product was incredibly happy, right? It made for faster response. People engaged more in our content, right? And so what were the results of that? When we increased performance, right, by making everything smaller and by being able to break out all these things, smaller packages, again, simple render, all of that stuff, performance went up by 3 times. And when that happened and we could finally start getting indexed by Google and all of that stuff, organic traffic, right? I mean, people who are literally searching, right, and coming to our site directly went up by 4x. And the big one was time on site, right? The time on site went up 600%. Okay, people were spending 6 times longer on our sites, right? And when you spend that amount of time, you're engaged. When you become engaged, you're more likely to pre-qualify and look at cars and really kind of get into what we can deliver. You start using all of our tools that we've spent hundreds of hours developing, right? And it actually drove business up, okay? It drove business up. We started generating a lot more leads to the point where we're actually, as of this year, we're actually monetizing our platform. Yeah, so we've actually been able to be good enough to make this an actual monetizable product. So we're selling it today, okay? So that part is the current story, but I'm super excited about Key Value Store. Now, we were lucky enough to preview Key Value Store. You know, and it's probably because the first time I heard it, I got on the phone with Alex and Tino, and I begged. I mean, I begged for it. I emailed them. I wouldn't stop pestering them for months and months and months, okay? Because this is what we see as kind of the next level of what we would like to do with this A/B testing, okay? One of the things that we know is that we have 5 megs, right, that we can remove from the actual function itself. Okay, we're no longer burning the candle at both ends, right? We can put far more functionality into the function itself because we're not worried about the exponential growth of the config file, right? Because you need to handle the parameter, then you need to house the parameter, right? Well, with that separation, we can now become way more flexible in what we want to do in the function and not worry about how big the config gets, right? Because we have plenty of room for that, okay? So the other beauty is there's no S3 there anymore, right? No S3. I don't need a pipeline. I don't need to release this, right? I just need to make an API call, right? Same thing that we were talking about the response body stuff, right? Now I can guarantee you there's zero, I should say it's 100% synchronization, right? When that key value store gets updated, the function and the return body will always be in sync, right? My client and my function will always be in sync. I'll never have to worry about invalidating cache. I won't have to worry about anything that's being called on the browser. All of that goes away, right? And it's a single API call, right? So as we were talking about all those cool off-the-shelf, API-driven, all of these things, right? ML and AI and all of these things, which we want. But with all the RTT, the return time, right? Just we couldn't use it, right? It was unusable if we wanted to get those performance and those enhancements. But now we could put that on the backside, right? So instead of APIs driving the determination, what we can now do is have those same systems, any one of those that we like best, and it can make an API call, and as often as we want, can dynamically allocate those tables globally anytime we need it, right? Once a day, once an hour, whatever, it doesn't matter, right? So we see this as game-changing as far as what we can do, right? And we're also leveraging the fact that, because we're at the edge, right? We're not talking west, right? We're not talking US West, right? You wouldn't leave Vegas, right? That's how fast you're gonna get these responses back, right? So what does that mean, okay? What do we see about, what good is it? Well, here's something. How about no code testing? How about straight HTML injection, okay? Now, our product has this thing called a CTA card, okay? That's a call to action, okay? And we love testing new variations of this, right? Different colors, different, all of these things, right? So, as you can see, that's the default one, the one that's circled in red, right? At the time of render, because we can get that config back so fast, and that we have so much room in the config that we can actually just inline HTML, right? When this goes to render, we can swap it out. We can roll the dice, know exactly which allocation that we should determine them into, and we can just directly inject any of those possible variants, HTML, right in that same square, real time. Now, your code doesn't have to blow. You don't actually have to re-release your MFE, your micro front end, and yet you can run all sorts of cool experiments because you're doing it offline in the key value store with your function that you can, again, update with an API call, right? Another thing that we look at is component testing. So there are some times, whether it's time to market, right, or MFEs that need to render on the client anyways, right, where you have those a single package that has both variants, right? As where it's like when it just can't be helped, okay? And we do have business rules, that do have this. Because we can, again, get that config back so fast, we can determine which one of these variants is actually going to be rendered before rendering, which means you don't get one and then it gets replaced, right? i.e. API calls, right? You can do this and you'll know before that component ever touches the screen. And that's kind of where we get very excited about key value store and cannot wait to get it into production because we can see how this will explode our experimentations. So thank you, and I'm gonna go ahead and pass it back to Tina.
Awesome. Thank you, Kevin and Harish. That's definitely a great example of how you can use CloudFront and Edge functions to experiment and gather the data that you really need to make business driving, impacting decisions for your product. They literally grew the Auto Navigator service from scratch, and I think it's monetizable now, right? Awesome. Okay, so with that said, we talked about caching, we talked about serving dynamic content, we talked about extending application logic to the edge. As you can see here, the trend is more and more is moving to the edge, and CloudFront and the CDN is becoming that front door to the internet for most applications. So much so that it's a best practice now to serve any HTTP public-facing asset out of CloudFront. Now what that means is we have to think about the threats at internet scale, right? So security has always been a top priority for AWS, And as we're able to see more and more of the internet data that's coming in and out of the service, we're able to make advanced decisions, continue to grow the service to the point now where it's actually a security service in itself. When we think about security within AWS, or within CloudFront, I should say, we're looking at it across a number of different pillars. We're looking at the infrastructure layer. We have to have protections in place to protect against things like DDoS attacks that will take down your resources and essentially your application, right? Over time, in 2012, actually, we started seeing a lot of DDoS attacks at the network layer, and our engineers started building capabilities that have actually turned into services themselves, such as Shield. Shield is our DDoS protection offering. The next area that we're really looking at is application security. We have to provide the capabilities for you to implement mitigations unique to your applications at layer 7. In 2015, we launched AWS WAF. WAF has been integrated into CloudFront since the beginning. Since then, between the two services, we're well integrated. We've added sophisticated capabilities that I'll talk about in the next slide, and we've made it easy to use for our customers. There's also secure connections that we need to think about. Encryption is important. I already shared that we cover TLS and we provide support for all the different protocols, but we have to make it easier for customers to use. A good example of this is ACM, Amazon Certificate Manager, is integrated with CloudFront. And when you want to serve HTTPS traffic out of CloudFront, we actually give you those certificates for free. The next thing that we look at is secure access. We also have to make sure that we provide the capabilities needed to protect your resources against unwanted or unauthorized users, right? So let's take a look at how this looks in execution. When customers often come to us looking to protect their endpoints, they usually have an origin that's either in an on-prem environment or maybe it's in an AWS region. And if it's HTTP public-facing endpoint, we say, put CloudFront in front of it. And there's a number of reasons for that. At layer 3 and layer 4, we have advanced mitigation capabilities built into the network. At our edge locations, on top of every rack, we have a service called Blackwatch. Blackwatch is a homegrown service that we built that inspects every network packet as it comes into our border and detects whether or not we should potentially drop that packet, right? We're looking at different profiles, such as if it's not an HTTP request, what's it doing here? Let's get rid of it. The other thing that we do when you use CloudFront is we're doing that inline inspection versus a reactive inspection and then mitigate, right? We inspect and then we drop right away if we detect that there's an issue. At layer 7, I mentioned we're deeply integrated with AWS WAF. WAF has progressed tremendously over recent years. We now have sophisticated capabilities for bot detection, rate limiting. You can create custom rules. We have AWS managed rules and partner managed rules to mitigate against common threats like SQL injection, cross-site scripting, you name it, right? It's well integrated within the service, and we've designed it in a way where it's easy to use. The last area that I want to talk about is CloudFront's always looking at our traffic. If you think about it, it's the service that's internet facing, and we're looking at largely most of the web application traffic that's happening over the internet. And when we do that, we're able to identify things. We're constantly evaluating the service for server efficiency and identifying vulnerabilities before they actually become threats. A good example of this is the HTTP2 reset attack that recently happened a few months ago. Many months before that, as part of an efficiency exercise, our engineers were looking at the code and identified, hey, there might be a vulnerability here. Let's put a mitigation in place to where it can't consume all of our resources. When the attack actually happened, we knew exactly what was happening, and we were able to mitigate it before there was any major impact to our customers. Now, when it comes to application security, you know, one of the things that somebody told me was security has to be easy, otherwise it's unusable. And when we talk to our customers, something that we learned is there's a couple different perspectives to look at when you think about security. You have your security teams that look horizontally across a large number of applications. They have very strict requirements, and they want to get in there deep and do deep customizations in terms of their security configurations. Then we have our application owners. Our application owners, they're looking holistically at their application stack. And for them, they value speed of onboarding and a unified experience. So we took that feedback and we looked at what we have. We have AWS WAF that provides all of those customizations that you can implement in detail. And then within our CloudFront console, we introduced one-click security integration, where you can actually configure a WAF configuration directly within the CloudFront console within a click. From there, we're actually looking at your configuration within CloudFront and coming up with recommendations that you can actually enable on the fly. You can start in a monitor mode to evaluate if these rules are working for your use case. We can detect if you're serving something like a WordPress application and go ahead and deploy that. On top of that, we introduced a security dashboard directly within the console. This security dashboard adds capabilities that make it a lot easier to investigate and understand what type of traffic you're receiving. You can look at things like where are your end users coming from? What percentage of your traffic is bot traffic? And then once you look at those things, you can actually take actions on them. You can decide if you want to block them, rate limit them, number of capabilities like that directly within CloudFront. Okay, so the last requirement that I'm going to go over is really more one that we're always looking at internally, right? The internet's not going to stop. It's going to get bigger and bigger. People are going to want to do more edge compute. There's going to be more data to cache. The volume of traffic is always growing, and we have to find creative ways to innovate to continue to grow our network beyond adding POPs to provide better experiences for end users. So over the past few years, we've actually been working on a new type of POP called the embedded POP. And we talked a little bit about this in previous sessions as well. But embedded POPs are POPs designed specifically for byte-heavy cacheable content, such as video streaming workloads or software downloads, popular software downloads. The challenge with delivering these workloads is they're very spiky. We've seen the traffic scale to up to like 12 times the average traffic pattern, right? Now, when we look at the capacity of our network, we realize that the constraint really isn't within the CloudFront network itself, but it's at the internet exchange points where we peer with local ISP providers. And because of the nature of the traffic being so spiky, it's not always economically viable to scale up these connections for us or the providers. However, it's very important because these bottlenecks can greatly affect a major event like streaming the Super Bowl or launching the next video game release, right? So embedded POPs addresses this problem, and how they work is, with embedded POPs, we deliver a rack unit, an appliance, essentially, to the local ISP. They partner with us, they deploy them within their data centers. These devices run CloudFront software, and we manage that software. What it allows us to do is get closer to the end users, serve content really deep within ISP networks, and relieve all that pressure off of the network for both the ISP and for the interconnect. It also increases our capacity and reach. And this is something we're actively scaling out over the next few months. Now, in terms of the value of these locations beyond the capacity requirement, if you think about the last mile, we're limited to how far we are from the end user from that internet exchange or that peering connection, right? And the internet is deep. Depending on the network, it can run really, really deep. So as we've observed this traffic, we've actually realized by deploying these POPs, we actually reduced latency for up to 65% in terms of first byte latency for some use cases, and we're able to offload pressure on the network of up to 95%. Where the real innovation actually is it's actually not in the caching technology itself or how we deploy the POPs, it's how we've actually built the POPs. If you think about it, these are devices that we ship to an ISP. We have no physical access to them like typical AWS infrastructure. So we have to build them to AWS security standards. So all of these boxes are built with really cool capabilities like host authentication, malware detection, firmware validation, all directly within them. We even have capabilities to actually self-destruct the device physically if we detect any type of tampering. Lastly, one of the things that we've been working on over the past few years as well is reinventing our CloudFront architecture. So on here, I have a QR code, and you can, if you scan that, you can visit one of the talks we did in the past that goes into deep detail under covers of how we've built CloudFront as a network and software architecture. When we first launched CloudFront in 2008, we were using what we deemed to be cutting-edge technology with Nginx and Squid, and it's worked great over the years. But something that we've realized over time is as new protocols advance, we need to be able to provide support for those protocols much quicker. And reviewing large pieces of code that might not be super relevant to CDN use cases isn't always best when you're looking to be really agile and deliver new features for our customers. So something that we've actually been working on over the last few years is building our own web server specifically for the CDN use case. And this web server is actually built on a new runtime that's actually managed by AWS engineers. And it's designed to be multi-threaded, to scale, and allow for edge compute use cases. Over time, we envision it to integrate well with native AWS capabilities like CloudWatch and S3. And we've already started deploying this across our POP architecture. So with the launch of HTTP3 and Quick, we actually started with that at the termination layer. And over the last few months and near future, we're working through our connection pooling layer as well. We're seeing already performance improvements of up to 100 milliseconds for some of these requests. All right, so with that said, that's the presentation that we have for you. And we have roughly 8 minutes, so we'll open up for questions.